So the goal for today in this video is we're going to describe how the letter of c affects the graph of ax squared plus bx plus c. So we know this is a quadratic function. We know it's going to make a U-shaped graph. Our question is, if I change this letter at the end, what is it going to do to my graph? So over here on the other side, I have Desmos prepared, and I've just typed in just a basic parabola, y equals ax squared. I can do that actually f of x. So I have just the parabola all set up. What we get to do now is we can change the values of a, b, and c. So the video before this, if you haven't watched that, tells us what a does. We know that a makes it skinnier, makes it wider, or it flips it over. So what we want to do is see what c does to our graph. So if I just hit play or if I slide my c value, very easy to see is that it's just moving my graph up and down. So the first thing, so c is responsible for two things that you need to remember. So c is responsible for two things. Now the first thing, obviously, is it moves the graph up. The second thing it does is it moves the entire graph down. Now more specifically, we want to notice when does it move up and when does it move down. So it's over here, what we can see is if we start it, let's say we start a at 1, so we'll have our basic parabola, 1x squared, b will be at 0, we'll start c at 0. If I make c a positive value, it moves up. So anytime it's a positive value, it's going up. So if c is positive, we go up that many units. So what I mean by that, if c was 6, we can see that the graph went up 6 units. If I set c to 1.4, the graph went up 1.4. You can see my calculator is rounding it to 1.39. Now, if I set it to a negative number, it's going to go down. So if c is negative, it goes down that many units. We'll do two quick examples here. So for example, what if we were asking ourselves y equals x squared minus 6 versus something like y equals x squared plus 1/2, and then we'll do a bonus of y equals negative 3x squared minus 4. So we approach the first one, we notice that there's a letter at the end, so that's our c value. It's a negative 6, so this graph should go down 6 units. And we mean compared to the parent. So again, over here, what I'm going to do is I'm going to add the parent graph. So just f of x equals, or y equals x squared. Doesn't matter what notation we use. Let's have an x squared. So there's our, here's our parent graph. Now what we should see is if I do x squared minus 6, it should be moved down 6 units. And we can see it is, like the vertex was at 0, 0, now it's at 0, negative 6. If you look at x squared plus 1/2, this value right here is my c value, so it's positive, so my graph is going to move up 1/2 of a unit. And again, that's compared to the parent function. So if I do plus 1/2, I zoom in, I can see that the original parent function had a vertex at 0, 0. Now the point was moved up to 1/2. If I look at this last one, we can see the c value here is a negative 4, so this is going to cause the graph to go down 4 units. But as a good review, there is an a value here from our last video, so the negative is going to cause my graph to flip over. And if I take the absolute value of that a, I get 3. And 3 is bigger than 1, so it's also going to be vertically stretched, which we might call skinny. So let's check that one here. Let's do negative 3x squared minus 4. Whoops. So here's our parent function, x squared, now negative 3x squared plus 4. So what we can see is that it was moved up 4. It's a little bit harder to see, but it is definitely skinnier. If I flip over the parent graph and then move it down 4, just so we can compare, that green one is definitely skinnier. So we are correct. So again, just make sure that you know that the c value moves the graph up or down based on its positive or negative.